Yesterday at 11:47 p.m. Eastern Time, 8 spacecraft images dropped into astronomical databases that nobody expected to see. What they captured of interstellar comet 3I Atlas doesn't just answer our questions, it raises one that Harvard's A.V. Loeb has been asking for months, and NASA finally had to address directly. Welcome back! On January 5th, observatories across 3 continents released the most detailed composite images of an interstellar visitor we've ever obtained. Not blurry dots, not telescope smudges, clear, structured photographs showing something that traveled here from another star system. And the timing matters because just 72 hours earlier, scientists completed something unprecedented. They scanned 3I Atlas for artificial radio signals. The results of that scan and what these new images reveal have ignited the most significant scientific debate since Oumuamua vanished in 2017. Let me take you back to July 2025. The Atlas Survey Telescope in Chile spots a faint object. Within days, follow-up observations confirm what seemed impossible: hyperbolic trajectory, extreme velocity, chemical signatures that don't match anything born in our solar system. The third confirmed interstellar visitor in human history. But 3I Atlas behaved differently. It started displaying jets of gas that curved in directions that made no intuitive sense, brightness fluctuations that defied our models, and a structure that some observers described as unsettlingly geometric. That's when A.V. Loeb entered the conversation. The Harvard astronomer who suggested Oumuamua might be an alien light sail proposed that 3I Atlas warranted serious technosignature investigation. And here's what most people missed: NASA agreed. The Breakthrough Listen program at the Green Bank Telescope turned its 100-meter dish toward 3I Atlas as it made its closest approach on December 19th. They scanned for narrowband radio signals, the kind that only artificial transmitters produce. The data came back on January 2nd. No artificial signals detected. But here's what the report actually said: no credible detections of narrowband radio technosignatures originating from 3I Atlas. That's not the same as saying it's definitely natural. That's saying we found no radio signals. Harvard and NASA just had their most public disagreement in years, and it happened in footnotes and carefully worded press releases. Now these new images arrive. The Gemini Observatory, Hubble Space Telescope, ground-based telescopes in Australia, and spacecraft at Mars all contributed data. When you stack 8 different observations from 8 different angles, you build a 3-dimensional understanding. And 3I Atlas revealed something nobody predicted. The coma, that cloud of gas surrounding the nucleus, shows asymmetry. Jets that spiral in a pattern several papers this week describe as non-random. Not artificial, they're careful to say, but structured in ways we don't see in solar system comets. The nucleus measures somewhere between 440 meters and 5.6 kilometers across. If it's on the smaller end and producing the water vapor detected, then roughly 20% of its surface would be actively outgassing. That's 4 times higher than typical comets. Our comets usually have 3 to 5% active surface area. Why is 3I Atlas so much more active? NASA's explanation: it formed in a different star system with different conditions. The James Webb Space Telescope confirms the carbon monoxide to carbon dioxide ratio is off by 15% compared to our comets. But Loeb's team points to something else. The outgassing pattern doesn't match what you'd expect from a purely icy nucleus. There are acceleration anomalies, tiny velocity changes suggesting non-gravitational forces. NASA says that's normal outgassing. Loeb's response: show me another comet with this exact pattern. Here's what both sides agree on. 3I Atlas is ancient, probably 7 billion years old, formed before our solar system existed. It wandered through the galactic fringe zone between spiral arms where old stars die and debris drifts in cosmic darkness. And then, by pure chance, its orbit intersected ours. What are the odds? If you're asking how many interstellar objects pass through our system every year that we don't detect, current estimates range from dozens to hundreds. We've found 3. How many did we miss? The European Space Agency tracked 3I Atlas with 10 times better precision than previous measurements. We can now reconstruct its path backward through the galaxy with unprecedented confidence. But we cannot identify which star it orbited 7 billion years ago. That star is probably gone. The system where 3I Atlas formed might not exist anymore. We're examining a fossil from a place in time that no longer exists. So what do these new images actually show? A comet. Definitely a comet. Ice, dust, gas, all the signatures check out. But a comet with characteristics we've never seen before, from conditions we can't replicate, behaving in ways our models don't perfectly predict. Is that evidence of anything artificial? NASA says no, Loeb says maybe, and we should keep looking. The scientific method says more data needed. 3I Atlas is now beyond Mars, moving toward Jupiter, which it will pass in March. By 2028, it crosses Neptune's orbit. by 2029, beyond Pluto. And then it's gone, back into interstellar space, carrying whatever secrets it holds. We'll never see it again. But here's what matters. When Oumuamua appeared in 2017, we weren't ready. We spotted it leaving and couldn't get good images. 3I Atlas was different. Every major observatory coordinated. Data flowed in real time between nations. That's years of planetary defense preparation paying off. Because someday, an object really will be heading toward us. So I want your thoughts. Do you think we're alone in looking up at interstellar visitors? If 3I Atlas traveled 7 billion years through dozens of star systems, what are the chances someone else saw it too? And here's the bigger question. Avi Loeb says we should assume some interstellar objects might be artificial until proven otherwise. NASA says assume they're natural unless proven artificial. Which approach serves humanity better? Write your answer below. 3I Atlas fades now, dimmer each night. Perhaps in a few million years it reaches another star. Perhaps someone there will scan it for signals too. Thank you for watching, and if you think more visitors pass through unnoticed, share your estimate in the comments. Until next time,